Today I will discuss about Booth algorithm. Why use Booth algorithm? Booth algorithm is used for multiplications of signed or unsigned multiplication method. You can use the two numbers using this like this way. You can use signed or unsigned numbers both. First, I will discuss what is the definitions of Booth algorithm. The Booth algorithm is a multiplication algorithm. Is an algorithm which multiply two signed or unsigned integer. This approach used to fewer addition, subtraction than more significant algorithms. Today I will discuss about the flowchart of how to flow up in a Booth algorithm. There are two things. Q and M is a multiplier and multiplicand. Load multiplicand and multiplier in these registers like in 4 and 5. 4 is a multiplicand and 5 is a multiplier. There is no any sign. This is only plus. So you can only calculate 1s complement and multiply it. So I am giving the board. This is the multiplicand M is added to registers Q. The result is stored in the register A. Then all the bits A, Q, Q minus 1 are the shifted to the right one bit. Depending upon the last bit of Q, single bit of the following arithmetic operations are the performance. I am giving the one things. In a flow chart, accumulator Q, QR, QL, you check Qn and Qn plus 1. If 1 0, then accumulator is equal to AC plus BR dash plus 1. Otherwise, AC is equal to AC plus BR. Sequence counter is equal to N. If 1 1 or 0 0, then shifting sequence counter SC minus 1. Then check it whether SC is equal to 0 since then end. Otherwise you can go in upside. This is the flow chart of Booth algorithm. First you put AC is equal to 0 and QR is equal to Qn and Qn plus 1 is equal to 0. It is the initialization. Then you check that is the 1 0. So accumulator is equal to AC plus BR dash plus 1. Otherwise AC is equal to AC plus B. BR. Next case 1 1 or 0 0. If 1 1 or 0 0, then you can simply shifting and the sequence counter minor. You can check sequence counter is equal to 0, then your process is terminated. Otherwise, it should go further. This process is definitely going. So I am giving you some examples about this thing. You can see that where 0 0, no arithmetic operation. 0 1, adding multiplicand to the left half of the product. 1 0, subtract the multiplication left half of the product. 1 1 is no arithmetic operation. This is the how to calculate 2s complement. Why use the 2s complement? If the sign negative, then you calculate the 2s complement. First you calculate the binary number, then it's convert 1's complement like 0, 1 to 0, 0, 0 and 0 to 1. Then how to calculate 2s complement? You can add 1. Then you can add 1, then you found that 1 0 0 1. This is the 2s complement of -5. Okay. This is the procedure how to add binary addition, like 1 plus 0 is equal to 1, 1 with 0 and carry with 1, 0 plus 1 is equal to 1 and 0 is equal to 0. Simply examples of the left side product and multiplicand. This way you can do add and take it 1 1 0 and 1 plus here 1 1 0, here 1 plus here 1 1 0 and 1 1 0. So here 1 is extra, then you can drop it. Most significant digits is to drop it. Okay. Then this is the binary subtraction. How to binary subtract? 1 minus 0 1, 1 1 0, 0 and 1 with carry. Otherwise 0 0 is equal to 0. This is the also the examples of subtractions. Okay. This hold. It's a start. I am also write this thing. So start A is the AC. Q1 minus 1 is equal to 0. It's the initialization. M is the multiplicand and Q is the multiplier. Our count is equal to N. It's also the sequence counter SC. Here you Q0 and Q1. If Q0 Q1 is a 1 0, so A accumulated key A plus M. Otherwise you can subtract with A plus M. Here you can subtract and you can add. If 1 1 and 0 0, then you can do nothing, only shifting, and you can subtract the sequence counter minus 1. Otherwise if your sequence counter is equal to 0, then you found as in. Otherwise no, then you can move cyclically. This is the examples here. This is the example. There is a 3 and 7. This is the multiplicand and 3. Q is the then convert 0 0 is the accumulator. Q 0 0 1 1. In a slide Q1 is equal to 0 and multiplicands. Here I am see that if 0 1. I am giving the another examples on board. One thing also discuss about how why use. This is used for the sign multiplications. This way you can calculate and in a binary. First you calculate the binary number, then you calculate first and then second for this number, and then multiply 7 number is also without 2s complement. This is the Booth algorithm. I think you understand. If you not understand, then you ask questions in classroom, another classroom. Okay guys.